What is neural network? Neural network is basically a mathematical function which maps the input to a desired. So first of all, I would like to give you my introduction. I am myself Jatin, and I am a sophomore at ADGITM Delhi. I am working with GDSC for past 8 months. I am a full stack developer, and I have also worked on many machine learning projects. Now let's start with neural network. So neural network is basically used to map input with the desired outputs. And in neural network, like you have studied yesterday about some basic machine learning algorithms about regression and classification. Those machine learning algorithms actually work really fine on some simple data set. But as the complexity of the data increases, we require some algorithms or something which can handle that level of complexity. For example, if you have to work on videos, images, audios, or text, like you have to have something which can work on that. In this case, we can use neural network. So, in this neural net, so basically, how does a neural network work? First of all, in this image, like you are seeing, the neural network is not actually like this. Like the neural network is actually actually a very complex mathematical function. And like any other machine learning algorithms, we feed training data into it, and it predicts output. During the first iteration, the data, the prediction that it makes is basically a garbage, because the but that feedback is used to train the machine learning model. And as the number of iteration increases, and as the feedback from and after consuming the feedback from the neural network, the accuracy of the neural network increases. And once you are satisfied with the accuracy of your neural network in the training data set, you can test your neural network on test data to check its accuracy and its working on in real life scenarios. So we have learned this much about neural network, but how does the neural network actually learns? For that, first of all, I would like to teach you all about activation function. Activation function are basically mathematical function that decides the value of a neuron in a neural network. It basically acts like a filter to whether activate a neuron or not. It basically takes the input and decides if the input data meets the requirements of the activation function, then it will activate the neuron, otherwise it will not. So there are some commonly used activation function. The first one is sigmoid. Sigmoid activation function converts the weighted sum to a value between 0 and 1. Here you can see this function fx equal to 1 by 1 plus e raised to power minus x. It is a smooth function. And second one is ReLU. Activation function often works a little better than a smooth function like sigmoid, while also being significantly easier to compute. Fx equals to max of 0 comma x. So there are many different activation function, example tan h, softmax. But if we consider these two, the ReLU has a slightly upper hand, and in some cases, and it performs better than the sigmoid function, because first of all, it is easier to compute. Second, it does not activate all the neurons at once. Yeah. So perception of artificial neuron with ReLU. So, as we have studied, the activation function of a neuron acts basically like a threshold or a condition to check whether to activate a neuron or not. First, it is very similar to if-then statement you have commonly used while programming. So first of all, it will take the input and check if the input meets the required condition. It will activate the neuron. otherwise it will not. And it helps to increase the non-linearity in the data. And it is the very basic thing which helps neural network to understand very complex data set and find some find some insights which are not so obvious. So let's take this example. In this example, our input is number 5, and our activation function here knows has learned to identify or to check if a number is less than 10 or not. In our case, the input is 5, so it is less than 10. Hence, it satisfies the condition, so it will activate the neuron. In this case, in this case, our input is an image of number 7, and our activation function knows how to check does it has a curve or not. It does not have a curve, so it will not activate the neuron. Perception. The next one is, oh, our input image is a number 6, so it will check does it have has curves or not, and in this case it has curves, so it will activate the neuron. I would like to tell you one more thing about this. The active the activation function. The activation function basically takes input and predicts whether it satisfies the condition or not, and it basically occurs in each and every neuron of the neural network. So now, if you this is a type of a convolutional neural network. So in this, the neural network, there can be several different layers. Some of the layers can be responsible for checking and differentiating on the basis of color, shape, size of tail, and many more things. And some certain layer might be responsible for checking the eyes, nose, whiskers, paws, and other things. So basically, why do we need this? Why does the simple machine learning algorithms fail to do so? Because the simple machine learning algorithms cannot handle the complexity of the data. These kind of data are really complex to compute with simple machine learning algorithms, and hence we use these kind of neural network. So first, in this, how does a connection can be student? Yeah. So let's talk about how does a neural network actually learns. To the neural network actually learns by three processes. By the process, the first step in that process is forward propagation, and then it checks the loss, and then backward propagation. In forward propagation, the input data is passed throughout the whole neural network, and then it generates a output or a prediction. After that, the loss function checks whether checks or matches that prediction or output with the actual data, the data which we are training on. And after checking that, it calculates the loss, and regarding that, with that loss, the back propagation updates all the weights in the neural network. The main aim of the back propagation is to minimize the loss, hence increasing the accuracy of the neural network. So some of the examples you have pretty commonly seen, like the AI camera or the image label verification. In this, you have very commonly seen, like while clicking images or in the Google Photos, the it can actually classify images, whether they are indoor, outdoor, trees, plants, animals, and portrait, and so on. So next, I would like to introduce to all a platform known as TensorFlow Playground. So it is a very amazing tool. With this, you can actually explore, visualize, and learn more about neural networks. without without any code. In this, like, you can see there are features, hidden layers, and output. In this, you can change the number of features, number of change the number of features and use different features, change the number of neurons in every layer, change the number of layers, and even change the activation function, even add or reduce noise in the data, or change the test train ratio. So the next one is the output. If you see on the right hand side, there's output. There's a graph in which there are red and orange and blue dots. Our aim in this is to segregate these blue and orange dot. So can we segregate these with a single line? Obviously not. So what would the most efficient way of segregating it? The most efficient way of segregating it would be a circle, which can be made from bunch of lines or functions. You can also see this that there is a test loss and training loss. So loss is basically difference calculated by the loss function between the training data and the data you are training on. Lower the loss, better the model. And our aim of every neural network is to minimize the loss. On left hand side, you can see the features. The TensorFlow playground provide you with some simple features. For example, vertical, horizontal, and the combination. So first of all, basically, what is this feature? Feature are the insights that we can derive from the training data. I would like to give you some examples. For example, dog and cat. In dog and cat, the features can be their shape, size, length of tail, paw, nose, whiskers. In case of house price prediction, the feature can be size of property, number of rooms, and the location of the property. In case of classifying numbers, the features can be number of lines, number of curves, and number of loops. So let's talk about hidden layer. Hidden layer is actually where the magic happens. In hidden layer, the model of our neural network learns and finds relationship between the data. So in this, first step, it forward propagates all the input data to the and calculates or generates output, and then with the loss function, with loss function calculates the loss, and the back propagation updates all the weights. I would also like to tell you how the neural network actually learns. The neural network actually learns with the weights and biases. The weights and bias, the neural network can strengthen the connection between two neurons by changing their weights. By the increased weight mean the higher its effects on the solution. So, and it is very similar to a dog and to or any other living organism. For example, like it when you give a treat or a pat on the head of a dog on successfully retrieving the ball, it is very similar to that because the neural network is basically a loosely model and inspired from brains on human brains only. Yeah, so the weights and biases allows neural network to learn by finding paths or discovering paths in the neural network that works best or gives the best output for a certain task. And after that, it biases those paths and makes it use those paths again and again to give accurate outputs. Yeah, so you can all visit this site. Here you will find some really cool exercises and tasks which you can perform on TensorFlow playground itself, and with which you can learn more about TensorFlow, neural networks, and visualize how the neural network actually works. So these are the exercises only. You can go through these exercises. So there is one more amazing platform, which is Teachable Machines. So what does this platform do? On this platform, you can train a computer to recognize your images, sounds, or poses. In this, like if you visit this website, will and go through the section image classification. You can actually create your own classes and put your own respective images of that classes. For example, you are creating dog versus cat. You are creating a classification model which classifies between dogs and cat images. In this, you can input create two classes, dogs and one of cat, in which you can upload your own images of dogs and cat, and it will train a model for you, with which you can classify those, and you can test those model in real life to see how it perform in the real life scenario. You should definitely check this out. It is an amazing platform, and which it is you can try it all. So basic overview. What is a I would like to give you an overview on this. What is a neural network? We all studied that a neural network is made up of neurons. It has weights, it has bias. The every neuron is connected to further neuron by some weights and connections. And how does it the neural network actually works? It uses forward propagation to generate or predict outputs, and then it calculates the loss and then uses back propagation to update weights. Second, what can it do that a simpler model might not be able to do? So the simpler machine learning models fails to work on or does not perform that good on data like images, videos, audios, and text. The neural network perform greatly on that. What is limitation of neural network or ML in general? So the limitation of neural network or ML in general is that first of all it is overfitting. It can be a limitation because sometimes our model, any model, may it be neural network or ML model, it overfits on the data, with which it can perform amazingly well on the input data, on the training data, but fail to work, but failed miserably on the test data. Second thing, the ML algorithms or any neural network actually require a huge amount of computational power, due to which for a long time the neural network were considered infeasible because it take high computational power. But now with the high processing power, we can use neural network, and it is being widely used. But still, you need some really good hardware and GPUs to actually make prediction, to actually use machine learning. So crowdsourced by Google. Crowdsource the Android is also available on Android as well as on web. It allows user to answer some really simple question in a gamified manner. With this, you can actually contribute to the ML community and help Google to improve its product. And this is some kind of interface, like you can answer simple question and earn badges. You can connect with contributors all around the world, improve Google product for everyone. By doing this, you are making a really big impact on the ML community.
Hi, I'm Nat.
And I'm Lo.
And this is our 20% project, where we go find out about different Google stuff we're curious about.
Last year, we got to make a documentary about how voice search works.
Kind of fascinated by it.
So today, we're talking with Greg and Chris to learn more about it. How would you describe machine learning to someone?
Well, there's a lot of problems that's really easy to solve with computers. Computers can go and simulate how galaxies move and how the courses of asteroids going and how close they're going to come to Earth. I could never hope to go and do that, but I can go and do this problem recognizing that that's a tree, which is so much tremendously more difficult for a computer.
It doesn't feel like intelligence to us because it's so effortless as a human being to do it, but for a computer, it's actually really hard.
because the real world is kind of messy and unpredictable at times. The strict logical rules that go into traditional programming just don't work.
Instead of going and writing programs that solve the problem, we write programs that learn to solve the problem from examples.
And it's this process of learning that allows them to improve over time and to actually be more clever than they would be if we wrote down a very rigid set of instructions for them to follow.
Machine learning is in so many different things that we use today that it's kind of like this invisible magic ingredient.
Phones with the ability to understand human speech.
Machine translation, email spam filters.
When you go to the ATM and you give a check and it can read the handwriting.
Or a Photos app that can automatically organize your photos based on the things that you like to take photos of. Like, here are all my mountain photos, here are all my food photos.
Here are all my dog photos.
Here are all my feet photos.
Everything from facial recognition to going and trying to recognize whether a particle is present in a particular collision at the LHC.
Which we would just like to take a time out to say is that big tube in the ground over in Europe that smashes particles together at really fast speeds so that scientists can use that information to unlock the mysteries of the universe, among other cool things. Now back to our episode, because I am getting really dizzy doing this.
So, researchers and scientists are still experimenting and trying to find the best ways to teach computers how to learn. But a lot of the progress is coming from these algorithms that are based roughly on how the human brain works, and these are called artificial neural networks.
So an artificial neural network is something that it's a rough mathematical cartoon of how a biological neural network works. In a biological brain, we have individual cells called neurons. Each neuron looks at what its neighbors has to say and then decide what it wants to say. And in artificial neural networks, we have little mathematical functions. We put them in some organized structure, and then we say, okay, you guys all together, learn to do this task.
We have lots of neural nets that are really great at going and recognizing, this is a cat, this is a dog, this is a frog, this is a mouse, this is a horse, this is a truck, and things like that.
So take, for example, trying to recognize what this is.
So it used to be that we were really proud if we could get a neural net with 3 layers to work. And it's recently that we've made a lot of progress on techniques that allow us to train much deeper neural nets.
And that's why this kind of machine learning is also called deep learning. A neuron in the bottom layer is just going to be looking at a tiny piece of the picture and making some computations about it. It doesn't understand anything about dogs specifically.
But what the neuron does understand is it says, I'm giving a signal that's useful for somebody who's giving a signal, who's giving a signal, who's giving a signal, who's giving a signal.
They're kind of able to unfurl this really high-dimensional knot and pull it apart and make it easier to go and separate different things that are close together on the surface from things that were tangled all together earlier.
But then at the top, we'll put 2 neurons, and these neurons look at the whole picture so far.
They're basically experts at making the final call, figuring out, oh, all the layers below me said these things, so I know that this is a dog, or at least I'm 92.4% sure that it's a dog, so it's basically a dog.
And while there's been a whole lot of progress with teaching computers to learn, they're still much slower learners than we are, and they make mistakes that you and I wouldn't.
So what I was working on is sort of trying to find a way to go and look at a neural net and ask, what does the neural net think the platonic ideal of a cat is, or the platonic ideal of a dog, or anything it can classify as? And suddenly you can go and ask, neural net, what do you think a cat looks like? And you get a picture of a cat. Or, neural net, what do you think a barbell looks like? So these weights. And it goes and it shows you a picture not only of a barbell, but of an arm attached to a barbell. So the model thought that the arms, it only learned what barbells were from looking at pictures of barbells, and they're often held by muscular weightlifters. And so it learned that there was, barbells have arms attached to them.
It takes them a long time to learn. You show it a picture of a school bus when it's early in learning. The very next time you show it a picture of a school bus, it's only a little bit more likely to say school bus. It doesn't get it, even though that was the very last thing it saw. Whereas, you say to a kid, that's a filing cabinet. And then a second later you say, what's that? Yeah. He's not going to be like, shoe, right?
Well, the more you describe this, the more I'm amazed by human beings.
Yeah.
The effect is like, wow, human beings are really amazing.
We're really amazing learning machines.
Oh. So thank you all for giving your precious time, and do definitely fill this post workshop form.